Welcome students. From today onwards, I will sharing with you pre-recorded video lectures so that at any time you can watch it, you can download it, and if you found any difficulty, then you can pause the video and clear your doubts. Okay. So in this lecture, I will discuss with you equations of ordinary differential equations of first order and first degree. Okay, as you know, what do we mean by first order means if y is a function of x, then its derivative, that is dy dx, is called the first order derivative. And second order means if we differentiate again with respect to x, that is d2y dx2 is called second order derivative. Okay, so this is called first order derivative means dy dx. And first degree means the power of derivative. Okay, so here power is 1, so this is first order first degree. Okay, and equation means equal to. Okay, and here function f is any function of two variables x and y. So how we write the general form of a first order first degree equation? Dy dx equal to f of xy. Okay, in another form we can write the same equation like mxy dx plus nxy dy. Here we have separated dx and dy. Okay, now we shall discuss the procedure to solve this differential equation. First one, as you know from your class 12, this was there, that is called separation of variables. Here you need to separate the variables. Okay, so our general equation is like dy dx equal to f of xy, and you have to separate the variables of x and you have to separate the variables of y and give the name f1x and f2x. Okay, so like f1x is a function of x alone and f2x is a function of y. Then what you need to do this, here numerator is dy and denominator is dx. Okay, so you have to take y, function of y along with dy, and you have to take a function of x along with dx. Okay, now the variables are separated. Okay, then you have to perform integration both sides and you have to add this c. Okay, because here c is a constant. Okay, and if you don't provide this constant c, then your solution is not called a general solution. Okay, so you can add c both side, but since left hand side c and right hand side c, if you take plus minus, this is also again a constant, so you just write a single constant here as plus c. Okay, so here you have to note it down that the constant c must be added in one side only. Okay, if c is not added, then the solution obtained will not be a general solution of 1. Okay, so what do you mean by general solution? General solution means all the solutions. Okay, for different values of c we get different solutions, so that is why if we include c, then it is called general solution of 1. Okay, so to simplify the solutions 3, the constant of integration can be chosen in any suitable form so as to get the final solution in a form as simple as possible. Okay, so to make the solution more simplified way of writing, we can add in c, and we can replace this c by like log c, tan inverse c, sin c, e power c. Okay, this kind of thing to make the simple form of solution. Okay, now these things you have to remember, like you know that log x plus log y equal to log xy, log x minus log y equal to log x by y, then n log x equal to log x to the power n, like tan inverse x plus tan inverse y equal to tan inverse x plus y by 1 minus xy, like tan inverse x minus tan inverse y equal to tan inverse x minus y by 1 plus xy, then like e power log fx equal to fx. So these formulas you need to remember. Okay, now let us do or solve one problem. Dy dx equal to e power x minus y plus x square e power minus y. Okay, so what we will do, we can write like this: e power x into e power minus y plus x square e power minus y. So if we take common e power minus y, what we have in the inside? E power x plus x square, right? Now this is a function of x alone and this is a function of y alone. Okay, so if we take this e power minus y in the left hand side, it will be e power y dy, and right hand side we have x square plus e power x dx, right? Okay, so if you do integration here, so you know integration of e power y is e power y, integration of x square is x cube by 3, integration of e power x is e power x, and you have to put this c is being arbitrary constant. Okay, so this is our final solutions. Understood? Then you do the next one: dy dx equal to e power x plus y. Okay, e power x plus y. Now do the next problem. Find the curves passing through this point 0, 1. This is the x value, this is the y value. Okay, find the curve that passing through this point and satisfying this equation. Okay, sine of dy dx equal to c. So what do we get? Dy dx equal to sine inverse c. Here c is constant, so total sine inverse c is a constant. Okay, so dy dx equal to sine inverse c. So what you get? Dy equal to sine inverse c into dx. Now if you integrate both sides, what you get? Y equal to integration of dx is x, so x sine inverse c. Again you have to add a constant, that is c dash. Now this is your curve, is not it? Y equal to fx is the curve, and also this is called also solution. Now in question it is given that find the curves, okay, passing through this point 0, 1. Okay, that means we need to find a particular solution. Okay, so if we put x equal to 0 and y equal to 1, what we get? C dash equal to 1. Okay, so y equal to x sine inverse c plus 1. So what we get? Y minus 1 by x equal to sine inverse c. So sine of y minus 1 by x equal to c. So that is your desired curves. Okay, next to see this problem. What is given? Dy dx into tan y equal to sine of x plus y plus sine of x minus y. See here, the x plus y and x minus y are inside the sine function. So by only seeing this problem, you cannot determine that whether we can able to separate the variables or not. So for that you have to apply the formula. So this is we will use the like sin c plus sin d. Okay, sin c plus sin d. So we know the sin c plus sin d equal to 2 sin c plus d by 2 cos c minus d by 2. Okay, so the given equation can be rewritten like this: tan y into dy dx equal to 2 sin this plus this will be twice x divided by 2, that is x, and cos this minus this, that is 2y divided by y is y. Okay, now you know that sin y, tan y means sin y by cos y. Okay, so what we get here? Sec y tan y, sec y. Okay, if you take sec y tan y dy equal to 2 sin x dx. Now here the variables are separated, na? Like in the left hand side we have only y separated, and in the right hand side we have only x separated. Now take integration both sides. What you get? Integration of sec y tan y is sec y, right? And integration of sin x is minus cos x. So sec y equal to minus 2 cos x plus c. C is an arbitrary constant, right? So this is our final answer, right? Now you do another problems. So dy dx equal to sin x plus x cos x by y into 2 log y plus 1. So by seeing the problem, you see that the x fx is in the numerator and fy is in the denominator. So these functions are already separated. Now what we need to do this, we have to take the function of y along with dy, and we have to take function of x along with dx. So do it and then integrate. Okay, you know the integration of sin x is minus cos x, and integration of x cos x. Now integration of x cos x is a polynomial So we can directly use the Bernoulli's formula that already I told you. So first function v1 means integration of cos x is sin x minus derivative of first function, that is 1, integration of sin x is minus cos x, or minus plus cos x. So you get this value directly, right? So then integration of y log y dy, so again do the same. So you don't the answer will be same because the variables are only changed, and we know that for integration variables doesn't matter, right? Okay. Plus integration of y dy, it is y square by 2, plus we have to add a integrating constant, that is c, right? So what is our final answer? After calculating, we get the final answer like this: x sin x equal to y square log y plus c. C is the arbitrary constant. Okay, so you just do the next one, right? Okay, so there are some problems that are quite easy, I think. So just let me discuss the last one. 3 e to the power x 10y dx equal to 1 minus e power x sec square y dx. So here you see that here is 10y, here is sec square y. Okay, so if you want to take if you want to take this part into here, so we have to divide both sides by 1 plus e to the power x, and we have to then if we delete this term 10y, and this will becomes here, then again we have to divide by 10y. So the whole term is divided by 10y into 1 minus e to the power x. Okay, so what we get in the first term, 3 e to the power x by 1 minus e to the power x, and second term will be x y sec square y by 10y dy, okay, equal to 0. Now our variables are separated and 10y derivative is in the numerator. So if we take integration both sides, okay, if you take integration both sides, and if you put this term as your t, okay, do yourself. If you put 1 minus e power x equal to t, what you get? Minus e power x dx equal to dt. Okay, so here will be integration minus 3 dt by t, okay, and integration 10 log of 10y equal to, here in place of constant you just write log c. Why? Because you know that we can write this term as log of 1 by 1 minus e power x whole cube, and this is like log of 10y. So log x plus log y means log ab. Okay, so this log of 10y by log of 10y by 1 minus e power x whole cube equal to log c, right? So you just get this value, final answer. Okay, so these are the, so you just do these problems. Okay, so here what you need to know is that you should know integration. If you know good integration, then you definitely can able to solve these problems. Okay, so already I teach you the formulas and the techniques how to remember this. Just remember these integration formulas, and your homework is these problems. Okay, exercise 2.1. okay, so here in this lecture we have learned how to find the solution or solution curve or the solution of a first order first degree equation using separable of variable method. Okay, in our next lecture we will again find out the solution by transformation of some equations. Okay, so thank you. If you have any doubt, you can ask me.